Math contest problem number 14. Linear Diophantine equation. The problem is, solve the Diophantine equation 27x minus 37y equals 4. Diophantine equation is an equation whose solution is confined only to the set of integers. In other words, we seek only for the integral solutions of the variables of the given equation. Example, 27x minus 37y is equal to 4. Now, in order to solve for the values of x, we need to have integral values of x and y that satisfy the equation. That's how we solve the Diophantine equation. Now let's have the solution. So 27x minus 37y equals 4. First, we let a be equal to 27, b be equal to negative 37, c be equal to 4, d be the greatest common divisor of 27 and 37, which is 1. Next, we set x prime and y prime such that 27x prime minus 37y prime is equal to the greatest common divisor, which is equal to 1. Now let's have the theorem. Given two non-zero integers a and b, where d is the greatest common divisor of a and b, then the linear Diophantine equation ax plus by equals c has a solution if and only if d divides c. Now in our case, our d is 1 and our c is 4. If the equation has a solution, then there are infinitely many solutions of the form x is equal to c over d x prime plus b over d t, where t is an element of the set of integers. Y is equal to c over d y prime minus a over dt, where t is an element of the set of integers. Now, to test if the solution exists, we first find d, and d, of course, is equal to 1. Since d divides c, or 1 divides 4, then the solutions exist. The solution set for x and y is given by, that's it. Now we substitute, so since c is equal to 4, so we have 4 over 1 x prime plus negative 37 over 1 t. The simplified form of that is 4x prime minus 37t. Now y is equal to 4 over 1 y prime minus 27 over 1t. Simplified form of that is 4y prime minus 27t. Now, to find x prime and y prime, we have the following. So we need to do Euclidean algorithm. Again, Euclidean algorithm. Now, in this case, negative 37 here is the p, and a is 27. So we have negative 37 is equal to 27 times negative 2 plus 17. Take note of the remainders. 17, 10, 7, 3, and 1. So this is the last non-zero remainder. So this is the greatest common divisor. Now, the backward approach. Negative 37 minus 27 times negative 2 is equal to 17, and so on and so forth. Now, for the backward substitution, we have the following. 1 is equal to 7 times 3 times 2. So, 1, of course, is the first remainder. That's why we started with 1. Next, we have, since the next remainder is 3, we substitute this value to 3. So that's it. And then 7, we have 7 here, and then 2 7s here. So we have 3 7s. So 3 times 7. Then 2 times 10, 2 times 10. Okay, now our next remainder is 7. So we need to substitute this to 7. So we have 3 times 7, 3 times 17 minus 10. And then we need to simplify. So we have 3 times 17, 3 times 17. Then 3 times 10 and 2 times 10 will be 5 times 10. So again, our next remainder is 10. So we need to substitute this here. So 3 times 17 minus 5 times 27 minus 17. So we have 3 times 17 and 5 times 17. So we have 8 times 17. Then 5 times 27. Our next remainder is 17. So we need to substitute this here. As a result, we have 8 times this minus 5 times 27, 5 times 27. Now simplifying that, we have 8 times negative 37 plus 16. 16 minus 5 is 11 times 27. So this will be the final result. X prime is equal to 11 and then y prime is equal to 8. Take note that negative 37 is B and 27 is A. The solution set is given by x is equal to 4, x prime minus 37t. Now substituting x prime by 11, we have 4 times 11 minus 37t, we have 44 minus 37t. Let's have the y, 4y prime minus 27t, y prime is 8, so we have 4 times 8 minus 27t, 32 minus 27t. So those are the parameters. For x is this, for y is this. Now the solutions are, when t is equal to 0, we have x equals 44 and y equals 32. When t equals 1, x equals 7 and y equals 5. When t equals negative 1, x equals 81 and y equals 59. And so on and so forth.